So when you look out your window, what do you actually see? A static landscape? Firm, unyielding ground? Well, I want you to completely rethink that for a second. Our planet is not just some giant static rock floating out there in space. It is a wildly active, ongoing masterpiece. Seriously, it's like a living canvas that is constantly being painted, erased, and repainted every single second of every single day.
Just think about it like this. What if the ground beneath your feet right now was actually moving? I know, it sounds a little like science fiction, right? But it's pure science. The rugged mountains, those deep valleys, the massive sweeping plains, none of them have always been there, and absolutely none of them are going to stay exactly as they are right now. We are literally standing on a massive, slow-moving work of art.
And there's a quote from the source material that hits the nail right on the head here. It says, "The Earth is a dynamic planet, constantly shaped by forces both from within and on its surface." So the absolute key takeaway is that there are two totally distinct teams of artists working on this terrestrial canvas. You've got the massive, fiery engines deep underground, and then you've got the persistent, carving elements right up here on the surface with us.
Let's dive into Section 1, Earth's Restless Interior, the engine powering the canvas.
To really understand the majestic mountains and the deep ocean basins all around us, we actually have to look thousands of kilometers below the surface. Because this is where the heavy lifting happens, driven by just unimaginable heat and pressure. And what's crazy is how incredibly thin our little comfort zone actually is. We live on the outermost layer, the crust, and it's surprisingly thin, varying from just 5 to maybe 40 kilometers deep. Beneath that sits the massive mantle, stretching about 2,900 kilometers down. And then, at the very center, you have the core. The inner core is this incredibly dense sphere made mostly of solid nickel and iron. It is so hot it should be melted, but the pressure is so intense it stays solid. And brilliantly, those specific metals in the core are exactly what causes our entire Earth to act like a giant, life-protecting magnet.
So, you might be wondering, how does all that intense heat way down there actually affect us way up top? Well, the answer is convection currents. Picture a huge, thick pot of soup boiling on a stove. The intense heat from the core warms up the material in the lower mantle, causing it to rise. Then, as it gets closer to the cooler crust, it cools off and sinks right back down. This continuous, circular motion acts exactly like a massive subterranean conveyor belt. It literally pushes and pulls the giant, fragmented puzzle pieces of our Earth's outer layer, which we call tectonic plates.
Let's take a super quick trip back in time to see how we figured this all out. Back in 1912, a scientist named Alfred Wegener noticed that the continents basically looked like puzzle pieces that used to fit together into one giant ancient landmass. He called it Pangaea. He proposed this idea of continental drift, but he couldn't actually explain how they moved. Then, jump to the 1950s, scientists discovered seafloor spreading. They realized new oceanic crust was literally forming at mid-ocean ridges and pushing the older crust outward. Today, those brilliant light bulb moments combine into the modern plate tectonic theory. It's basically the grand unifying theory of geology. It explains the earthquakes, the volcanoes, and the whole layout of our continents.
Okay, moving on to Section 2, Sculpting the Surface, the chisels and brushes of nature.
If the internal forces are the heavy lifters pushing the raw canvas up, the external forces are the detailed sculptors. They are constantly grinding it down, reshaping raw rock into the beautiful landscapes we actually live on. But before we meet these surface artists, it is absolutely crucial to clear up a common mix-up: weathering versus erosion. They are not the same thing. Weathering is the process of breaking down rocks right where they sit, in situ, no movement yet. It's just fracturing the rock. Erosion, on the other hand, is the active carrying away of those broken down particles to a totally new location. Basically, weathering prepares the paint, erosion actually applies it across the landscape.
You want to see some quiet, terrifying power? Just look at physical weathering in action. Say rainwater seeps into a tiny little crack in a solid rock. At night, the temperature drops, that water freezes into ice, and it expands. This simple expansion acts exactly like a crowbar, widening the crack. The ice melts, more water gets in, it freezes again, and the cycle just keeps repeating until that solid rock literally bursts apart. Nature's patience is incredibly effective.
But once the rock is broken, nature needs a transport system to move it. Enter the river, nature's premier sculptor. A river basically goes through a three-part life cycle. First, you have the upper course, or the mountain stage.
Up here, gravity pulls the water fast and hard, eroding downwards to gouge out deep gorges and steep V-shaped valleys. Next is the middle course, the plain stage. The river hits gentler slopes, slows down a bit, and starts to weave and meander, cutting into its banks. Finally, the lower course, or delta stage. The river is practically crawling now. Right before it merges with the sea, it drops all that fine sediment it's been carrying to form these highly fertile deltas.
It's amazing when you see how this all flows together. Follow the water from that rocky, high-energy mountain source at the very top, carving straight down through those sharp valleys. Then, as it enters the middle section, you can really see those wide, sweeping curves developing as the water slows down and swings from side to side. And finally, you get that sprawling, fan-shaped delta at the bottom. It is a continuous, flowing conveyor belt of Earth. But hey, rivers aren't the only artists out there. We also have glaciers. These are massive, slow-moving rivers of ice that travel at a total snail's pace, but they have so much sheer weight that they gouge out massive, wide, U-shaped valleys. Then you've got sea waves relentlessly pounding our coastlines, tearing down cliffs, but also building up beaches. And out in the arid regions, like the Sahara or the Thar Desert, the wind is the master sculptor. It easily lifts dry particles to sandblast rocks and build these massive, constantly shifting sand dunes. Which brings us to Section 3. The major masterpieces, the resulting landforms.
So, when the internal engine pushes up and the external forces carve away for millions and millions of years, what is the final result? Well, take mountains, for example. Actually, not all mountains are built the same way. You have fold mountains, like the mighty Himalayas or the Alps, which are created when tectonic plates crash together, crumpling the Earth's crust like the hood of a car in a really slow-motion crash. Then you have block mountains, like the ones around the Rhine Valley. That's where massive chunks of land crack along fault lines and are hoisted straight up or dropped straight down. And of course, volcanic mountains, like Mount Fuji, which are literally built from the inside out by layer after layer of lava and ash.
But it's not all towering peaks. We also have plateaus and plains. Plateaus are basically broad, elevated tablelands that just abruptly rise up above their surroundings. The terrain is usually pretty rugged, making construction tough, but they are incredibly rich in minerals. Just look at the vast Tibet Plateau, famously called the roof of the world. Contrast that with plains. These are those vast, flat, low-lying expanses built up over ages by rich river deposits. They're fertile, level, and super easy to build on, which is exactly why they are the most thickly populated areas on our entire planet. So, we've built this beautiful, livable, perfectly structured world. It sounds pretty balanced, right? Well, what happens when the canvas fights back? What happens when these slow, majestic forces suddenly snap?
Section 4. When nature strikes back. Disasters on a dynamic planet. Here's the terrifying truth. The exact same geological forces that give us our fertile plains and stunning mountains, they don't always operate on a safe, predictable timeline. Sometimes that physical energy builds up, hits a breaking point, and just releases in a matter of seconds, causing absolute devastation. And the contrasts are extreme. High up in the mountains, rapidly melting glaciers can form massive lakes held back only by weak natural dams of loose rock. If that dam fails, we get a glacial lake outburst flood, sending an apocalyptic wall of water rushing downstream. Now, compare that to a totally different nightmare, a severe dust storm. Fueled by drought and high winds, these massive walls of sand can literally blot out the sun and destroy agriculture. Two completely different disasters, both born from the exact same dynamic Earth. And then, of course, we have the sudden, violent events driven by gravity and tectonic tension. Earthquakes happen when tectonic plates that have been grinding against each other finally slip, releasing intense, sudden energy. And that violent shaking, it acts like a trigger for the next two hazards. Landslides, where entire steep hillsides of rock and earth come crashing down. And avalanches, where heavy layers of snow and ice roar down mountain slopes at terrifying speeds. It's basically a massive geological domino effect.
Now, I know this all sounds super daunting, maybe even a little scary. But here is the great news. We are not entirely helpless. We can use our understanding of this dynamic planet to protect ourselves through mitigation. And that falls into two main buckets. Structural mitigation is all about physical engineering, stuff like designing flexible buildings for earthquake zones or building strong retaining walls. Non-structural mitigation is all about our behavior and planning. This means creating accurate hazard maps and, critically, using proper land use practices. For example, simply preserving thick vegetation on a hillside is amazingly effective because the plant roots naturally bind the soil together so it doesn't just wash away.
Which brings us to our final thought today. The Earth's surface processes have been shaping this world for millions of years before us,
and they're going to continue long after us. But humans, we also act as vital agents of change. Cutting down trees indiscriminately degrades the land, and careless building accelerates our risk of landslides. We are really just temporary residents on a living masterpiece that is still being violently and beautifully painted every single day. So the ultimate question we have to ask ourselves is, what brushstrokes will humanity leave behind on Earth's living canvas? Thank you so much for joining me on this explainer. I really hope this totally transforms the way you look at the world right outside your door. Keep exploring, keep questioning, and I'll see you next time.